we were discussing about the beat distribution along the air gap of a rotating machine. We considered a single stator coil, if you recall, only a single coil, which can have multiple turns. Okay. And if you pass DC current, to draw the MMF, we are assuming we are passing DC current. It will not at all be difficult to sketch the waveform if it is a time varying current. That I will tell you, give you hints, very simple. But anyway, and suppose there is the rotor iron and rotor has not got any coils to begin with, that is what I told. And if you do this, these fundamental things always you apply to convince yourself what is what. For example, here the lines of forces will be doing like this. So, this stator, this surface will become a south pole, and stator this up will become a north pole, and this is the developed diagram, that is, suppose I have cut it like this, spread it around, then one will appear here, one dashed here, same currents, and this coil, this is a coil, means at the back they are joined, it could be a multi-turn coil, and then this is the current. So, along the flux lines will be, if you consider any flux line, it will cross the air gap twice, and it will also complete its path via the stator iron and the rotor iron. Under the assumption that the permeability of iron is infinitely large, very large, so that we conclude that no MMF is necessary to send flux lines through the irons. So, all the MMF will be consumed to establish flux in the air gap of the machine. Air gap is that thing, stator inner surface and rotor outer surface, the separation, that is LG. So, doing this, we ultimately last time I told you, if you have a stator coil like this, nothing wrong in repeating that, so that it is really understood. It is a multi-turn coil, it is also a multi-turn coil, and this is stator iron, and here is air gap, and this is rotor iron below. And then against the distance space, if you sketch B or H, BG, HG, generally G I will avoid later after we get accustomed with it. Then if these conductors are carrying dot currents and these conductors are carrying cross current, constant magnitude, then what you do at the center of these slots, you draw two vertical lines, and between them it will remain constant, and it will switch over to negative sign, because lines of force here are like this, south poles, and here the lines of forces will be like this. So, it will be like this here, till once again you will see this 1 dashed and this is 1 symmetric square wave, plus to minus you will get. This is B or H, and here, as I told you, it will this jump from here to here by applying Ampere's circuital law. One could do furthermore detail, that is, you go by a small distance, what is the current enclosed, like that it will go on increasing, let us assume like this. That linear increase or decrease we neglect, we just say vertical. Okay. This is how B distribution is, because after all slot width is very small compared to the pole pitch of the machine. Anyway, this is the B distribution. Now, this B distribution we now know will decide what will be the nature of the generated voltage in a conductor, which may be housed on the rotor surface and is rotated. So, same B distribution will be the induced voltage polarity. That is why knowing the B distribution pattern is important. This is x distance, and where is x equal to 0 is your or my business. You can set okay, the x equal to 0 is here. That is not very, I mean one has to of course fix where is x equal to 0, then he knows everything about this waveform. Now, this is fine, but as I was telling, our intention is to get sinusoidal voltage generated. So, to get the sinusoidal voltage generated, I would expect that B should be made also sinusoidal. Then no one can contest me. If B distribution is sinusoidal, your induced voltage too will be sinusoidal. But it is not going to be, as we are seeing a single coil like this. At best you can say okay, it has got a strong fundamental sinusoid with lot of odd harmonics with reduced amplitude. Perhaps you can neglect those and only fundamental you can say. For example, if such a square wave voltage is applied to an RL circuit, how to analyze that? I will say that this I will Fourier analyze, get a fundamental, then third harmonic, then fifth harmonic with reduced amplitude, and for the fundamental if I pretend that okay, these amplitudes are too small compared to these, their effects on current will be less, and you satisfy okay, this is sinusoidal voltage. Of course, in detail it can be analyzed. Fundamental you find out the impedance root over R square plus omega square L square. For third harmonic, the impedance will be root over R square plus 3 omega L whole square and so on, and for each of them you will get sinusoidal terms and add them up to get the total current. But target is to get a very strong fundamental sine wave, that is to be done. Now, how this can be done? One way of doing this, at least trying to get to that sinusoidal thing, is to say that okay, instead of a single coil, why not use several coils which will be connected in series, and that will alter the shape of this BH curve. How this can be done? What I mean to say that in terms of coils, let me draw. What I want to say that so long I have taken a, I will draw very fast, let this be very bad drawing, but it must go to your head what I am telling, that okay, so long what I have done, I have taken a single coil and two pole I am restricting it. So, these are the two slots. Oh, I drew it other way around. So, let me just put it. So, here I put one coil, is not, this is 1 dashed multi-turn coil, I am just showing one, this is one. Now, what I will do, I will place another coil 2 dashed and 2. These slots are diametrically opposite, and when they will carry current, they will produce two poles. I know that. Now, what I will do is this, I will have 1 dashed, say this is 1 dashed. Electrically what I am going to do now, 2 dashed, this there are two coils separated by some angle or space, whatever it is, 1 dashed, 2 dashed. and then I will connect them such that current enters through one and come back to that is connect a source here, and then the distribution of the current will be 1 cross, 2 cross, and these two are dots, is not. Now, I last time gave you an exercise, okay, what happens to this, but you see this pair of coils carrying currents in this way also produces two poles. Why? Because these two cross can be grouped together and it will produce lines of force like this, and these two dot can be grouped together and this will also produce a lines of force like this. Therefore, any band of cross current distributed over space and opposite side dot currents which are also equally distributed, in effect there is as if a single coil in middle and producing a field. So each one produces two poles, resultant will be like this. So in that case what happens is this half will become south pole, and are you getting, and this half will become your north pole like that. You can easily see. So, instead of using a single coil, if I use two coils which is named as 1-1 and 2-2, and each of them are and they are connected in series, so that they are carrying same current, then what will be the resultant waveform? Resultant waveform will be then, first I draw the developed diagram of the system. So, this is suppose from this side I am drawing. So, this is suppose 2 dashed here, then after a little bit of this you will see this 1 dashed multi-turn coil, I am not drawing, okay. This is 1 dashed, then you will see 2 as you go this way, you will go 2, and then after 1 2 1 2 you will get 1. So, pole pitch is this one 1 dashed or 2 dashed, whatever it is. Now, I have connected the coils as I told you in this fashion. So, I reproduce the current distribution in space by dot and cross marking, and I want to examine what will be the resultant field. Okay, resultant field will be 1 dashed is a coil. If I find out its resultant field, 2 dashed will be a single coil, find out its flux density distribution, and just add those two waveforms to get the resultant. That is the whole idea. So, this is stator, and let us see how this B distribution changes. This stator iron and this is rotor. Assume rotor is having no coils, even if it is having coil it is not carrying current. So, this is rotor iron, and this is your air gap which is very small in length Lg. Now, this distribution here what I will do, I will sketch B distribution due to 1 1 dashed, and I know for this single coil 1 and 1 dashed B distribution will be like this here. Is not. What will be the B distribution due to coil 2 2 dashed? B distribution due to coil 2 2 dashed is in this graph I am sketching. It will be similarly like that, because for a single coil I know how to sketch it. So, it will be like this. And these two coils are identical, same number of turns. So, their amplitudes will be also same. And this is the, see, in rotating machine, of course, I was writing last time I also wrote distance. This is not really very correct, in the sense that the moment you have developed it and it is rotating structure, you can show the position by some angle theta. Are you getting? Are you with me? Because this is the thing. So, a particular position in space in a rotating environment is to specify the angle with respect to some reference point where you are. So, instead of distance, we can write theta position. Okay. Although we have developed the diagram, but that theta will also get translated here. So, theta position. So, the B distribution is with respect to position. So, here it is theta, mind you. I hope you have understood the point. So, this is the thing. Now, what I will do? I will add these two waveforms to get the resultant, that is all. B due to both 1 1 dashed and 2 2 dashed, that is what I am going to do. So, here in this zone you can see, suppose this is how much, N I by 2 L G, na? N I by 2 L G minus N I by 2 L G is this level. This is also N I by 2 L G, because the coils are identical. Therefore, during this zone it will be this plus this. So, it will be higher like this. During this interval it will be this plus this. So, during this interval what will be the value? How much? Is it correctly drawn now? Everything is fine. So, during this zone it will be 0. So, it will be 0, and during this zone it will be once again 0, and thereafter in this way I can go on adding these two MMF obtained separately for each of the coils and add them up. And then here on this side it will be negative here of this amplitude. Got the point? Therefore, you see earlier there was a distribution like this, which was sharp pure square wave. Now, we will have stepped waveform. In fact, the MMF distribution or B distribution can be made like this here. I will give one example with different slots. Instead of earlier it was like this, something like this. Now, it will be like this. I can make it like this by using more than one coils. Are you getting? This is suppose the 0 level. So, there will be some 0, but using 3 coils I can also make it like this. I leave it to visualize these things. Instead of 2 coils, if you use 3 coils separated by same distance, 1 dash, 2 dash, use another coil 3 dash, and add them up, you will get a waveform which may resemble like this. And this one is visually is much closer to sine wave, what I am trying to tell ultimately. Therefore, to make the B distribution sinusoidal, first conclusion is better do not use a single coil. You for a two pole machine only, a single coil produces 2 poles, but have a distributed coil, that 1 dashed, then 2 dashed, then why not 1 dashed, 2 dashed, why not another coil here. And let this be 3 dashed dot. The resultant field will be once again 2 poles, but the nature of the waveform will be now stepped somewhat like this, and it is much better. If you Fourier analyze it, you will find the once again it will have a strong fundamental, and third, fifth, seventh, all those harmonic B will be there, but their amplitudes will be much smaller compared to the amplitude of this waveform. This is how you approach a sinusoidal. You cannot do anything better than this in a rotating machine. The Fourier analysis of such a waveform, as I told you, will have a strong fundamental, in Fourier analysis, you know the next harmonics. In this case, it will be all odd harmonics, mind you, no question of even harmonics. So, strong fundamental, then will be third harmonic, and the amplitudes you know generally decreases by 1 by n. So, that way its amplitude will go on decreasing compared to the fundamental. Then fifth harmonic, its amplitude will be further less harmonic. Therefore, in such a scenario, you have to construct a machine to have sinusoidal B distribution. Why sinusoidal B distribution? Because you want to generate sinusoidal voltage. Therefore, using a single coil to have a space variation, theta variation of B sinusoidal, no, that is not possible. That is pure rectangular square wave like inverter output voltage. Then what is the way out? Way out is, instead of using a single coil, you use several coils to make a group and pretend that this is the single coil. Okay, it produces 2 poles, and the B distribution here will be more closer to a sine wave. Later we will see that by disposing the conductors in a particular fashion, that is this angle should be how much and things like that, we will show you that it is possible to 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 nullify the predominant harmonics. One predominant harmonics at least can be eliminated by properly choosing the angle by which angle between two subsequent conductors of a particular group. Therefore, this is the thing what is done, that is, do not use a single coil, use distributed coils and get a stepped B distribution. Mind you, this is B. You can select your origin wherever you like, but that you must fix up, then you can only describe this, and this is the space angle theta. With respect to that it will be like this, then we argue that okay, this waveform is not sinusoidal, but certainly better than the earlier proposition where a single coil was used, because it looks more like a sine wave, which mathematically means that the strong fundamental of this one is really strong, and third, fifth harmonics, well, any seventh, ninth, all these things will nonetheless will have reduced and reduced amplitude, they can be neglected. But the point I want to make is okay, it is the question of predominant harmonic, whether predominant harmonic can be done away with by doing something tricky. We will show you this can be done. So, conductors are that I will discuss after few lectures, but the point is better do not, if you have to use a single coil, better do not use a single coil, distributed coils. How many distributed coil, amount of space available, this that is there, then you can use the coil span as a variable to see that predominant harmonics, a particular predominant harmonic is eliminated. Then we have own many things. I mean, first thing is you have made it more sinusoidal, then you are telling I have done this so that third harmonic will not be there. Third harmonic is the most predominant harmonic. Most predominant harmonic will have highest amplitude among the harmonics. So, that if you can neglect, then okay, higher order harmonics can be eliminated. Okay. Therefore, this is how a sinusoidal B distribution will be obtained, and if you take a generator mode of action, then rotor conductors, if it is moved by a prime mover, it will have a voltage of this form only, but I am telling that voltage will be more closer to a sine wave. And there are methods by selecting span of the coil, etc., you can reduce even a desired harmonic. And in our next class, what we will do, we will in fact start windings. Now, with this preliminary understanding of the things, we will show you how to make windings of a induction motor, AC windings of an induction motor, or that of the stator of a 3-phase squirrel cage induction motor, things like that. So, from our next class we will start windings. Do not miss that, that is very important. You must go through that, so that everything together you must have an understanding of the whole thing. That is, it is not that in piecemeal. My approach is this, that okay, from very fundamental things, how real things are approached, that is what I am trying to tell you. Thank you.